You have learned Pascal's law, correct? And you have also learned about pressure. You also learned about hydrostatic paradox. Now let's try to see where this Pascal's law is applied. Okay. One of the major applications what we have is hydraulic lift. All right. Hydraulic lifts. Guys, you have heard about hydraulic lifts in many cases. I'll give you a very simple example for a hydraulic lift. See, whenever a car gets punctured, they have a particular device to lift the car up so that they can change the tire. That is a hydraulic lift. Okay, that is a hydraulic lift. See, the concept of hydraulic lift is very simple. We use Pascal's law here. Now, what does Pascal's law tells you? That if you apply pressure on one part, that pressure gets distributed all over it equally, correct? Now, this is the same principle what we are using here in hydraulic lifts. All right, a very simple thing. Okay, now look at this particular figure. Now here you have two columns. One is a small column, one is a big column. When I say small column, the area is smaller, call it as A1, and you have the second one, call it as A2. All right. Now here A1 is very much less than A2. Like A1 could be in few centimeters square and A2 could be in couple of meters square. Understood? So A1 is very much lesser than A2. Next, what we have, what is pressure? Pressure is equal to force by area. We know this one. Now, according to Pascal's law, the pressure has to be the same in both the cases, correct? In the sense, when you apply downward force on the small column, there has to be an upward force in the second column, that is the bigger column, isn't it? But pressure remains the same. You have P1 is equal to P2, or F1 by A1 is equal to F2 by A2. Now, what is the force in the bigger column? That is what we are trying to calculate. F2 is equal to A2 by A1 into F1. Correct? See, we know that A1 is very much less than A2. Like A1 is very small. So what happens? F2 becomes very much greater than F1. In the sense, even if you apply a small amount of force in the smaller column, you are going to have a large amount of force in the bigger one. This is exactly the principle what we use in lifting the cars when the car tire gets punctured. Okay, so we are going to apply small amount of force, but that force can lift a car, isn't it? This is basically a hydraulic lift. Okay, in a hydraulic lift, what happens? You apply small amount of force in the smaller column and a large amount of force gets transferred onto the bigger column. Okay, now this is basically hydraulic lift. Understood? The formula, mathematical formula is very simple. You have F2 is equal to A2 by A1 into F1. Understood? Now, depending on the A2 A1 ratio, you can say that F2 is it going to be very much bigger, or you can just make it a little bigger. Understood? This is an example of hydraulic lift, whatever you just considered. And this is the application of Pascal's law.